Okay, everyone, here we'll try one more time. This is C2 scaling methods. I'm here with Doug Darby. We're sort of sitting out in the hall and we're working on his data at the Marriott in San Antonio. So coming to you from halfway around the world, here we are. Doug, if you'll just tell us a little about your data, where it comes from, and then we'll dive into it.
Okay. So my data was derived from a survey I created called the Experiential Influences Survey. And the intention of the survey is to assess or to examine the perceptions of the role of prior experience in adult online learning. Survey has 4 demographic questions, 10 items that specifically look at the role of experience in learning, both for knowledge and skills, sort of tentatively, and then 1 qualifying criteria that talks to online learning specifically. And
how many subjects?
So I did the survey monkey and received a total of 53 responses, but there are only 51 that were usable. So that's what my data set is consisting of.
Okay, now let's see how it looks.
Okay.
So I think let's share the screen. Yeah, we're starting to share.
Okay.
Great. And cool. Let's see how this looks.
Okay.
And so one of the first things we might do, and we've probably already done, is just to review and see if the items make a reasonable scale.
Okay.
Like that is the relevant items. And so to do that, go ahead and try. We do an analyze. And,
do you want to do factor analysis first?
Yeah, let's just go to scale to remind everybody, and reliability analysis, run Cronbach's alpha on those. One of the things this will tell us is, Doug knows, but we don't, whether all the items are coded the same way or some are negative worded or things like that. We're about to find that out.
Do you want to include the criteria or just
not the criteria,
okay.
Just the attitude items in this case,
okay.
Or the opinion items, and we'll do a statistics option, and then we'll click on item, scale, and scale if item deleted, and then continue. So once we press OK here, we hope it'll run. And what comes out is a Cronbach's alpha of 0.72, which is not bad. It's respectable. And what I'm looking for down here, if we scroll down under corrected item total correlation, none of them are negative. And so I have no suspicion that any of the items need to be reversed or anything like that. Okay. So they all seem to be the same direction worded, presumably positive, but I don't remember exactly what the items were. Mm-hmm. So, okay, so let's jump into factor analysis, which is method number 1 of the 3 that we'll be working on, and that's dimension reduction and factor. And that works okay, and we'll use the same items, and I think Doug probably already has it set up, but under extraction, statistics will be okay, usually as default. Extraction, we want to make sure we get a scree plot. He's already clicked on it, so that's good. And then if we look down under rotation, what we want is an orthogonal rotation. Varimax is the one that does that, so that the factors come out at 90 degrees to each other, and we'll continue on that. And then options. I always like to suppress the small coefficients and sort by size so that it's easier to look at what to name the factors if it comes out to be more than 1. So let's just press continue and see if it'll go. And press OK now. And it looks like it ran. It looks like it's going to try to pull out 3 factors and account for 69% of the total common variance over there to the right. Let's scroll on down and see what the screen looks like. And I would say, wow, this is a very unusual configuration with two constructs that are so high relative to the floor, to the base. Mm-hmm. So there are definitely 2 constructs in there, maybe even 3, possibly 4, but we only have 9 items total, right?
10.
Oh, 10. So yeah, it makes We would hope there are not 4 factors in there. We hope there are smaller numbers with each with a greater number of contributors to it. So let's go down and see what the rotated component matrix looks like. And it's grounding out 4. It appears there's one pretty strong factor at the beginning, PK8 and PK5 and 7, and we'll just take a peek at what 8 is.
So 8 is, as far as the question, 8 says, it is helpful for me to connect what I learned from one course to another.
Okay, and then 5 is?
5 says, I learn more effectively if I relate materials to what I previously learned.
Okay. Well, anyway, those are pretty strong loaders, but we're going to mash it into 2 now. So let's rerun it and see if that's meaningful. Because 2 were indicated as so strong on the screen plot. And so we'll do, I believe it's extraction. And we'll take off the eigenvalue 1 default and specify 2 factors. And then rerun it. And then, yeah, press OK. I think that's all we have to change. So this is interesting though. Your version, this raw and rescaled, is a new split screen view for me. We must have clicked on something.
Yeah,
unintentionally, but that's okay. The screen plot, I guess, looks the same. The rotated component matrix gave us now.
We're going to get rid of something to.
Yeah, let me see if we can rerun this and turn off some of the clicks.
Okay. What I did there.
Under factor, let's see on rotation. We might have clicked on something we didn't want. Very max rotated solution. No, that seems okay. Extraction maybe. It seems okay. Fixed factors too. Go ahead. Maybe we added some descriptives we didn't want by accident. I'm not sure. Nope, there's only 1 click. Time options, I guess, is all it's left. And I don't see what caused this.
I don't know.
Yeah, it seems like since 30 minutes ago, we might have magically been upgraded to some SPSS version we didn't see before, but that's okay. We'll figure this out. So go on to OK. That. This is, we'll go to the bottom again. And so our rotated component matrix, raw component, rescale component, seems to be, I'm not sure that I see. Where does it cross over?
It's like, okay,
right.
1.
And all of these go all the way down. Oh, it's just the last item.
4.
Yeah, so item 4 is by itself a single component. And let's see what that is.
Okay, that would be,
if we try to say this is 2 factors.
It says, I learn equally well with familiar topics and those that are entirely new to me.
Oh, so that's new and old topics, which seems to be in a different realm. Oh, okay, well, this data set, and by the way, Mark Stout just joined us, so we'll say hello to Mark.
Oh, hi.
And this is interesting because Mark's data is
I need mouse ears.
there you go. We'll, I think this is a great example to drill down more at this level. I'm curious as to why 4 would be hanging out on the limb all by itself. So what we have, it looks like, is a 2-factor structure. We're going to go to cluster analysis, or cluster analysis immediately, and see if it has a different view about number 4. As we've said in several sessions, these runs, I kind of get my eye on one or two items. And right now, I'm wondering about number 4. The rest of them seem to behave fairly normally. And so to do that, we're going to do a classify run, and it's going to be hierarchical cluster analysis. And we'll put all the same variables in there. PKO1 through 10. And just to let you know, we're recording, so just in case.
That's why I wanted the mouse ears.
I see. Okay. In case you want to be polite or something. Here we are there. Okay, we're going to cluster variables. And the plots are, I think the plot, click on the plot with the dendrogram, click on the top button. Probably horizontal is easier to see, and it's much easier to print when you want to make a printout for your paper later. So we'll say okay and see what comes out. And what comes out now is it ran, so down at the bottom. Okay, well there's a cluster, and guess what? Number 4 is way out on the limb. Also with cluster analysis, so starting to get a hint here that in the view of these respondents, number 4 is in its own universe.
This looks too
and
detached.
I'll just say when we're all done here, if this were my data, one thing I rarely ever say just throw away item and rerun a factor analysis. But I'm getting the hint now that Doug might want to just, when we're done with all of this, he might want to just remove item PKEO4 and rerun everything. And see, by taking out the other universe, you could get a cleaner image of the.
So it doesn't skew everything.
Right. Yeah. But let's continue on for right now to multidimensional scaling. And see, it will probably put that number 4 way out on the extreme and everything else. So to do that, we'll analyze. And it's under scale, I believe. I've been looking for you. And we're going to the last one here, multidimensional scaling, null scale. And same items as we've been using on the other 2 runs. PKEO1 and down to number 10. And then if we look at we want to create distances from the data. And then Euclidean distance is okay. And then we want to check on the model. And yeah, let's keep it at 2 because we're expecting this one item to be on one extreme. And start with a 2. It's a flat paper representation. It's a good place to start. Continue, and then I believe under options, we want a group plot to make sure that we get that one, and continue. Then, so we'll do okay, and let's see what came out. Oh, it ran. That's a good sign. And, yeah, down to the bottom. So, what do you think, Doug?
4 is. This is interesting.
Yeah, well, first of all, 4 way is out in left field by itself, literally to the left.
Detached from the rest of what's being looked at.
And it almost looks as if you just deleted 4 and then you're continuing to delete this way.
Which would make more sense.
Right, and so as Doug pointed out, number 3 now emerges as far away from all the rest of the group. And let's see what number 3 is.
Yeah, 3 says my existing knowledge of a topic affects how much I learn in the future about that topic.
Okay, so remember the purpose of multidimensional scaling is just to say what are the minimum number of dimensions we need to fully explain the distances between the objects. So what we see here is number 4 is a great distance from everything like we expected. It's also true that number 3 in some sense is a great distance from the rest of the clusters.
Yeah.
This might have implications for refining your scale later. Because these are all close to each other. outside of 4 and 3. And it may be that you wind up looking at the rest except for 4 and 3 and see how that comes out through Cronbach's alpha, through factor analysis, hierarchical cluster analysis. But it's only in this analysis that 3 has popped out. It may be, it may be meaningful as the other end of what we see as the y-axis scale now. So what we're going to do now is just see how well we did with 2 dimensions. If you can scroll up and see, so this, with 2 dimensions, explain 99.6% of information, which is a lot. And so we're going to rerun this once and just see what happens when we mash it into 1 dimension. And that'll be under all scale. This time we'll run it to 1 and 1.
Same thing as everything.
Yeah, we'll just leave everything as the way it is and see what the picture looks like now. So we're looking at 2 things. Which way did it collapse through the hyperspace projection from 2 dimensions into 1? And it looks like what happened is that 4 is still way out in left field, but 3 got merged into the other group, which is again confirming that 4 looks like the culprit. Let's go up and see how much was explained. Still, 99% of all the information can be recaptured from using 1 dimension. So right now, if we have all of these objects, we have, we could say, let's leave them all in and put them on a straight line. But if you look at the plot, what we really have is almost several on top of each other. And it's because having 4 in there forces all the others to be in such close proximity scale to each other. So my conclusion here would be repeat all of this, just take out number 4.
See what difference it makes.
Right, and just, unless there's some absolutely essential reason. It may be 4 is an outcome item, it may be that it's a disaggregation of data item rather than really an attitude item. So, Doug, any thoughts?
No, I mean, this is the only thing that surprised me was seeing that PK3 sort of pop out there, because there's no, I didn't really get a sense of that when we did the initial factor analysis.
Right.
And so being able to shift and seeing this from that 2-dimensional perspective was very interesting. But this seems to be consistent across all dimensions.
It is, and so if you get rid of 4, you may see that 3 starts to emerge in some other form through these other analyses. So, which
is what I mean. This doesn't surprise me. This was sort of interesting. So it just tells me that there's a dynamic going on that it's just not apparent right off the bat. That's causing it to shift out. So.
Yeah, and probably if you go back and look at the items and skim down the data, you may be able to see by scanning why that probably is.
Okay.
But
so maybe the next step would be just to try see what happens when we do this, and then run through all of those again.
Exactly.
Okay.
All right. Well, that's the end of this session. This may be the world's shortest, and we'll stop the recording.
Okay.
There.
Cool.
So we'll stop sharing, stop recording, and then